Now this illustration deals with feeders, not branch circuits, and the general principles and rules are found in NEC 215.2 A1 and A1 but the sections in the API do not change. It's 1.1.1 and 1.1.2. Now let's review the notes first. The notes instructs us to use 215.2 A1A for determining the ampacity using method 1 as required in 215.2 A1 a. Note 2 says also use 215.2 A1 for determining the ampacity in method 2, but we're also using 215.2 A1 b. And then note 3 says use the larger of the ampacity to determine the methods 1 or 2, which one we would want to use. And of course, you know, this feeder was in 220.14 and as well as 220.17 of the NEC. Now, the next thing, let's review the top of the illustration, and it says the non-continuous load is 95 amps. The continuous load is 90, I believe 8 or 6 there that we're looking at, and I believe it's 8. And then notice that we have 4 current carrying conductors in the raceway routed through an ambient of 122 degrees Fahrenheit. Once again, the raceway system is over 10 feet or over 10%, and we're out of the 86 degrees Fahrenheit listed in table 310.16. Now, with that information provided, let's look at method 1, calculating the load at the left-hand top side of the illustration. And in step 1, we're doing our math. We take the non-continuous load at 100%, the continuous load at 125%, and we come up with 217.5 amp. But the loads at continuous or non-continuous added together is only 193. But we would need a number 4 alt to supply 217.5 amp because the 4 alt, is good for 230 amp. Now method 2, we're taking the 100% rule based upon adjustment and correction factors. And to do the math, we're coming up here with 100% loading, which is 193. Now we take 80% of the 300 kc mil conductor, that's good for 320, because we have 4 of them in the raceway, and our table 310.15 C1, by the requirements of 215.2A1B, says we take 80%. So we come up with 256 is the new ampacity of that 300 kc mil conductor due to 4 of them being current carrying. Now we take note 3. Note 3, we apply table 310.15 B1 based upon the routing through 122 degrees Fahrenheit, and we come up with 82% for that conductor based upon the insulation of that conductor. We would select the 90-degree column, select the 82% for that temperature, do the math, 82% at 256, we come up with 209.9. That would require a 300 kc mil conductor to supply the 209.9 amps that we have there, which would be the size conductor we would need instead of the 4 alt in method 1. And that's what this figure 8-15C is illustrating, the calculation for adjustment or correction factors when a feeder's involved.